My name is Ben, 3D specialist with Chaos Group, and welcome to Visualizing BIM, Realistic Rendering for BIM Projects with V-Ray for Revit. Before I get started, I'd like to add that all the imagery in this presentation was taken from V-Ray for Revit, minus a few images from Max, but I'll call those out as we go along. First, a little bit about myself. David did a good job explaining all this already, but there's also my email address if you'd like to get a hold of me directly. Alright, so a brief overview of what we're going to go over today, which includes a brief look at our design philosophy behind V-Ray for Revit. We'll then go over the major features of V-Ray for Revit while preparing a scene to be rendered. First thing I'd like to go over is that there's essentially two types of people who produce architectural renderings. There's the designer and then there's the visualization expert. The designer is someone who treats the rendering as essentially one tool in a large toolbox. Visualization is important, but the primary focus is not the image, but the design that results from it. While the visualization expert is someone whose primary role is to produce high-quality imagery, where the primary focus and the final result is the visualization. And V-Ray for Revit was created with designers in mind. Here's a selection of renderings that were created with V-Ray for Revit that showcase what you could potentially create during the different stages of the design process. Like this was done using a simple kind of 3D print plastic material. This one was done as a simple white model using what's called a tune material to create the black outlines. And then this one would be considered more of a final rendering with final materials, final lighting, etc. And along with this one is a rendering courtesy of Karam Baki, which is a interior shot. And then we're moving along, we come along to this image, which was rendered in V-Ray for Revit, but it showcases the work that would be produced by 3D specialists. This one, it's essentially a work of art in itself, and this was actually created by our Bulgarian 3D artist team, which they typically specialize in visual effects, and they were able to create something pretty amazing straight out of Revit, with a little bit of post-processing, of course. But moving along, this is something that was created in 3ds Max by a company called Tomorrow Visualization in Sweden. This is the Gensler's Gateway Tower in Chicago. And this was what would be considered something done by a specialist as opposed to a designer. And the same with this one, which is also done by Tomorrow Visualization. This is Hyperloop 1 in Dubai, designed by BIG. So a little bit of background of how V-Ray for Revit came about is we listened to the opinions of designers like you in creating the plugin. This was to take V-Ray in a new direction compared to how our products have been in the past. And the idea was to make it simple and fast and easy without sacrificing quality. And a quick comparison between the tool sets for Max and what we put in V-Ray for Revit. This is the typical V-Ray for Revit, V-Ray for 3D Studio Max interface, which was designed for visualization specialists. But while it's extremely powerful, it's also difficult to jump into and start using right away. And this is actually just a fraction of the tools available in Max. If you switched it over to expert mode, you could fill this whole screen just with the settings alone. But V-Ray for Revit was designed to have everything available right at your fingertips. So all the basic things that you need to just jump in and start rendering is available in its own separate ribbon toolbar within Revit. And the idea is that Everything is important. All your important features are readily accessible, and it fits within existing Revit workflows. So everything that you're already used to with rendering within Revit is available here for you to just quickly jump in and get going. Right, and the project we're going to be using for this presentation is the Barcelona Pavilion by Mies van der Rohe. We recreated it in Revit, and we'll be providing a download link later on. Actually, I'll have to send a link to Microsol. But let me show you how easy it is to just jump in and start rendering. So here we have the project, and all that we need to do is simply select a view, select a quality setting, and select a preset. And we can start rendering. And you can also change the lighting and the exposure, but the default values are already ready to go for a daylit scene. And we just hit render, and there we have it. So what V-Ray is essentially two rendering engines in one. There's V-Ray, which was formerly known as the production engine, which is what, if you've used V-Ray in the past, what I'm sure you're used to using. And then we also have V-Ray Interactive, which is also known as V-Ray RT. Both have their strengths and weaknesses, and both can be used for production. And I'll go through each one. First we have the V-Ray engine, which is typically best for final images. It has more options for global illumination, also abbreviated to GI, which helps you produce a final rendering faster. And it also works best with Swarm, which is our distributive rendering solution, which I'll go over towards the end. And then V-Ray Interactive, or V-Ray RT, is the rendering mode that supports your GPU. So if you have some powerful hardware, this will actually get you a final image a lot faster. Changes in the environment and the camera update in RT while you're rendering. And you get results, you'll get an initial result a lot faster, like what's in this screenshot here. And then over time, the image will refine and get smoother and nicer. But if you're doing design iterations and you want to just get a quick general idea of what the image will look like, just start an RT rendering and you'll get a noisy image this right away. Okay, so with that, we're going to go ahead and jump into the process you would go through to produce the final rendering. So we'll start out with materials. Now by default, V-Ray for Revit supports all the materials that you can produce or which are created by default in Revit. So you don't necessarily have to do anything special. But for higher quality images or final quality materials, you can easily go in and create your own, or we also provide a library of materials along with V-Ray for Revit to choose from. And for our model, let's go ahead and change this water that's in the foreground here. And to do that, we just simply need to open the material browser. And here you're presented with all the materials that are already in the project. And each material you can change it from AutoGen, which is the default Revit material, to a V-Ray material, or if you want a simple diffuse texture or color. So what we're going to do is we're going to look up the water material. And we're going to switch that from AutoGen to a V-Ray material. And I already have a material set aside for this, so I'm going to go ahead and assign that. And just like with Revit materials, you can set the sample width and height, and you can set a rotation to make sure it fits properly in your scene. And this little button here brings up the material editor, which allows you to edit the V-Ray material. And the editor allows you to select from a wide array of kind of simple presets with a small selection of settings you can change, along with different material preview scenes. But for the advanced users, you just need to switch to the Advanced tab, and you have all of the ability to change the most complex parts of the material, if you wanted to, of course. and then you just simply save the material when you're done. But here we're just going to close out of it because we already have the water material that we want. So if we go ahead and hit render, you'll notice in the foreground the water material will change to the new V-Ray material. Right, so moving on, V-Ray for Revit also includes an advanced global override system for materials. It allows you to easily produce renderings without the distractions of materiality, which is great for, let's say, light and spatial studies or basic massing models, which is great for kind of design iterations, or if you want to show a client the design without having them focus on materials. You can just show them the basic kind of the light features and the spatial features of the design. But it also allows you to produce faster progress renderings, like let's say you're setting up the lights and camera in a scene and you don't want to spend all the time rendering the materials. This allows you to quickly set those up before you produce your final rendering. But it's very quick and easy, and all you simply need to do is you set one material for your opaque materials and one material to replace all your transparent materials. And here's a few examples that we created that were done pretty quickly with the basic sample scene. On the top left we have what's called a tune material that's overlaid on top of a glass material that creates this cool kind of conceptual effect. On the top right we have a marquette wood material that's like a basswood. On the bottom left we have a chipboard material. In the bottom right we have another 3D print kind of plastic material. But we'll go ahead and go through the process of setting that up. Just open your material browser, go to your global overrides tab, and just enable your overrides. And by default it creates these light gray materials which look fine, but I'm going to fine-tune some of these settings to make something a little nicer. And you have the ability to create some really nice simple materials with just these few sliders, but you can also create your own. You can use VR map materials just like you can with the individual material replacements. And then moving on, I'm going to change the view for the next for this next rendering I'm going to do. And I'm going to use this kind of exploded axo view. So I'm going to go in and instead of using these colored materials I made, I'm going to use some pre-made materials. I'm going to use the marquette wood, which is the basswood material. And I'm going to make this large so it appears like it's a scale model. So I'm going to set this to 10 meters by 10 meters. And same with transparent material, I'm going to use a glass. And I just need to change my view, and then I'm going to change my resolution since this is more of a square aspect ratio. Now this time I'm going to use the RT rendering. This way I'm able to navigate around inside the model, and it will update in RT at the same time. So just need to go to the view, open up the navigation wheel, and you'll see it'll update. And material overrides are great for doing a live demonstration like this because it makes the model render much faster. So next we'll move on to the environment. There are many advantages to how V-Ray treats the environment for your Revit scene. Changes made to the environment update in RT, for example. V-Ray also takes full advantage of the existing sun system within Revit. So any changes, it takes your location and time of day and translates that into the sun location inside your rendering. You can also use a solid color or an image, such as this example provided here uses an image that both lights the scene and provides the background. Okay, so we're going to stop the previous rendering. Change our settings back to what they were. And start an RT rendering again. And so the first thing I'm going to do is I'm going to actually modify the sun settings for this view. So if I go to the rendering settings and modify the sun settings, and I can easily change the altitude, for example, hit apply, and it will update an RT in real time. When we created V-Ray for Revit, our intent was to try to keep as much inside Revit as possible. So everything that you're already used to using will work with V-Ray for Revit as much as possible. And I'm also changing the azimuth, rotating the sun around the model, and it updates. And I'm also changing this to still, so this is where it's using the location and the time and the date to move the sun to the proper location. And then, of course, if you change the time to sometime after the sun sets, your rendering will come out black because there's no sun. And this uses the same advanced sun and size system that is available in V-Ray for Max, SketchUp, and Rhino currently. I'm setting the settings back to default, and I'm going to make some adjustments to the sun itself. These are specific to V-Ray. For instance, the sun size. The sun size, really, the only reason to adjust the sun size is to affect the blurriness of the shadows. So if I change this to 10, you'll notice that the shadows will start to blur. If you focus on this shadow over here underneath the overhang on the left side, if I increase this to 24, the shadows become really blurry. This is great for conceptual renderings because it's actually not physically accurate unless you leave the sun size to 2. And then you can also change the sun intensity if you want, which just makes the sun, not as bright. Okay, moving on, we're going to change this to the dome light. And the dome light gives us the ability to use just a simple color that provides the background as well as the lighting for the scene, which can be good for like an overcast rendering, let's say, or just something crazy and conceptual. But the real value of the dome light comes when you use an HDR image. Now we come with this one HDR image by default, but there's plenty available on the internet for free or for sale that you can use. And it's using, like I said before, it's using the image both as the source of light and as the background. But the default one is a little pixelated because it's a low resolution image. And then if you set it to no light, it just disables the environment completely, which is kind of similar to what Revit itself can do. Okay, moving on. Next we have the camera settings. V-Ray Interactive, or V-Ray RT, will update as you move the camera in Revit, as we saw previously. But there's also an exposure and white balance controls to easily modify your camera. And you can also affect the depth of field by modifying your defocus amount. And finally, there's optical vignetting controls available. So if we go back to our scene, I'll go ahead and hit the exposure button to bring up your camera settings. And you'll notice as I change the exposure, it affects the rendering as well. The smaller values make it brighter, similar to how an actual camera functions. And then white balance, you can easily make the entire image warmer or colder with the simple slider. And then if you expand the effects area, you have depth of field, which you can change with the defocus slider. Just simply move it to the right and the camera begins to lose focus. You'll also notice that it's focusing on an area about 7 meters away, and we can just simply type in a new value. Like let's use 26 meters, which is the distance to this column in the background. And then we also have optical vignetting, which is as simple as moving the slider to start applying the effect. You'll start to notice the edges of the image are starting to get darker. Okay. Up next are the camera modes. There's several different camera modes available to achieve more than the standard static imagery that you've been seeing up to this point. There's the standard camera, which obviously just creates the basic image, but there's also stereoscopic, which creates an image that can be viewed in 3D. There's the VR camera, which generates a cubic map, which is what you would use to create an interactive panorama. And then there's the stereoscopic VR camera, which combines both, so you can make a 3D interactive panorama. And this is what you would use to put in a VR, a virtual reality headset. And then I'd recommend going to labs.chaosgroup.com, which has an excellent guide on how to get imagery into the various VR headsets. Each headset, like the Oculus or the Google Cardboard, for example, have different preferred methods and image sizes and etc. to use, and it's an excellent guide to kind of get you started. And this is a quick video of a panorama I did in one of the projects that we have here. This is with a VR camera, so it wasn't stereoscopic, but this is an example of what you can do. And this was created, I'm showing this to you using what's called Panellum, which is a free open source web-based panorama viewer that I found. But it's just an example of what you can do and how you can showcase your work to clients and etc. So moving on to fog. There's two different types of fog available in V-Ray for Revit. There's what's called aerial perspective and environment fog. Aerial perspective, which is actually the scientific term for the kind of hazy effect that you see on objects that are farther away. It's used to simulate that effect, but you could also create an image like what you see here, where you can create something that looks more like a typical fog. And then there's environment fog, which is a more accurate simulation of fog that calculates volumetric lighting. So then you get effects such as the sun passing through the fog, creating God rays. So we're going to go ahead and open up the fog settings here, and we're going to start with aerial perspective. And you can see it immediately start to affect the image. Now when you change the view distance, that'll make the fog denser and lighter, depending on which values you enter. And you'll also notice that it does not affect the background. This is because the haziness with the atmosphere is already taken into account when you are rendering the background, but if you enable Effect Environment, it'll override that and create kind of a stylistic effect. And with the environment fog, you'll notice as soon as we activate it, it makes the entire scene darker. This is because environment fog actually affects the lights passing through it. So obviously if you have a ton of fog, it'll make the scene much darker, and you would just adjust your exposure to compensate. And you'll also notice, such as the overhang on the right, you'll notice that you can actually see the shadows projecting through the fog using this. Moving on to artificial lights, V-Ray for Revit right now supports all the lights that are already in Revit, so all your IES files, all of your shaped lights, your spotlights, etc. They're all supported by V-Ray for Revit, so you don't have to do anything new, as long as the families are, of course, properly set up and they don't have like a light source stuck inside of a piece of solid geometry, for example. But we support all the properties, so all the shapes, all the color variations and intensities, we support all of that. So what I'm going to do is I already set up some lights in the scene, so I'm going to go ahead and enable my lights. First I'm going to switch the view because I have a night view already set up with the sun at a much closer angle to the horizon. I'm going to enable artificial lights and start RT. And you'll notice right off the bat you don't see any of the artificial lights. This is because the sun is already a little too bright and the exposure value needs to change. So I'm going to go ahead and modify my exposure value and sun intensity to kind of get the image that I'm looking for. And with just a few quick tweaks, I'll get to the amounts that I want. Right. Then with that, we're going to get this ready for a final render. And before we get started, I want to go over a couple of things real quick. The first of which is the DENOISER, which is something that we introduced in V-Ray for Max recently and has been in V-Ray for Revit since release. The DENOISER intelligently smooths the image, allowing you to stop the render early without an abundance of noise. Although it's typically best to let the render go for as long as possible, because if the image is noisy, if it's too noisy, then you may start to lose detail in your textures and in your geometry. And this scene, as you can see on the right, the raw renders on the right side of the image, and on the left is the DENOISER. And then we also have color corrections. These are the post-processing effects that are available in the frame buffer, which is the render window. And it allows you to easily fine-tune your images without putting the image into a third-party editor such as Photoshop. You can also save and load your images to use, your correction settings to use in different images. And these adjustments can be made while the rendering is still going or after it is completed without affecting your render time. Okay, so I'm going to go ahead and stop the RT rendering that we had going before. I'm just going to change the quality, change the resolution. Then I'm going to go to my channel setting and enable the DENOISER. And the default settings are usually fine, but you can also tweak these as much as you want. And then we'll just hit render. Now once this is rendering, I just need to hit the Show Corrections control button, and then I'll have all these post-processing controls, such as exposure, for instance. Now this is more of a post-processing exposure setting, It's best to use your exposure setting and your camera settings to get it close to where you want it to be, and this is just a fine-tune adjustment. Same with white balance. I'm just going to tune it a little bit. And then, like similar to how Photoshop is, you have hue, saturation, color balance, levels, and then I'm going to go ahead and change the color curve for this a little bit, just to get the brightness and contrast about where I want it to be. Alright, now I'm going to go ahead and speed up this video a little bit. And then you'll notice, if you look at the top left where it says RGB color, that's going to change to effects result in a second. An effects result is the denoiser pass. And you'll notice that the image will smooth over as soon as that happens. There it goes. And then if I use this button next to that, it'll switch between the RGB color, which is the raw render, and the effects result, which is the denoiser. Now this rendering is still going, and you'll notice that a few areas still don't look very good, like the reflection under the window on the right. But if we let it go a little bit longer, it'll clean up in the raw render, which will affect the denoiser as well. And there we go. And this was about 15 minutes into the rendering, and this was about, I would call this finished, but I'm going to go ahead and let it go for 15 more minutes, and you'll see it clean up just a little bit more. All right, I'm going to go ahead and stop the render. Of course, you could save this as is, and I'm going to also show you, you can see the difference between the raw render and the denoiser and how much it affects the noise. Like in this reflection right here in the middle, as soon as you switch it over, it's nice and smooth. Right, a couple more things I'd like to go over before our time is up. V-Ray Swarm is our distributed rendering solution. It's designed to scale and work in a render farm or in your existing workstations on your network. It works in low priority, so you can actually have it running on machines even while users are using them. And it only uses the resources that the users aren't currently using. So if they're using Revit and they're doing a lot of things, then it's really not going to use their machine very much or at all. But if they're just reading emails or something, it'll use that extra processing power to help your renderings finish. And then it's also easy to throttle the usage to say you want to use a certain percentage of your available machines or all of them. It's very simple to do even while it's rendering. And then you can also categorize and organize machines, so you can only use certain ones as opposed to others. And I'm going to go ahead and demonstrate how Swarm works. We just enabled Swarm. And I'm also changing my engine settings to use buckets. This is because buckets works better typically with distributed rendering. But it will also work with progressive as well, which is the default setting. And now while it's rendering, you'll see that there's now, I can expand the distributed rendering area, and you can actually modify this bar here, which sets the goal. And this is the ideal amount of percentage of machines on the network to use. And then once I set it to 100 and the scene transfers, you'll notice that now all of a sudden I have all these other machines. And you'll notice there's an abbreviated set of text in each bucket, and that represents the name of each machine on the network that's kicking in and helping with the render. And moving along, something more for the visualization specialists out there is new in 3ds Max 3.5. We have a new import VR scene function, which allows you to take VR scenes, which you can export from any of our other products like V-Ray for Revit or SketchUp, etc. Bring them into Max with all the geometry, materials, etc., similar to a V-Ray proxy if you're familiar with V-Ray proxies. That way you can use the advanced features in something like Max without having to recreate what's already been done in Revit, such as the materials and mapping, etc. Excuse me. So I'll show you real quick how easy it is. Just set a quality and hit export. And just save out your scene. Well, the reason I changed the quality is because it actually affects your mesh density as well. And in Max, all you need to do is create a V-Ray scene object, open the scene, it brings it in. I'm just going to adjust the camera a little bit and hit render, and there it is. It's a V-Ray ready project straight out of Revit.